Today we'll be continuing our three-part series on advanced derivative rules with something called the product rule. And as you can probably guess, the product rule is used when you want to take the derivative you want to take the derivative of a function that is the product of two other functions. So for instance, if we have a function h of x, which is the product of f of x and g of x, then the product rule tells us that we take the derivative of the first function and multiply it with the second function left alone, and then we add on the first function multiplied by the derivative of the second function. I expressed that in English here, but I don't know that it makes it a whole lot clearer. One of the ways that I'll sort of express this a little more informally is to say that the derivatives basically take turns. You've got f and g here, and each of them want to be a part of being the derivative. So first we let f be the derivative, and g waits their turn, and then we add on, f stays the same while we do the derivative of g. In the rest of this video, we're just going to do a number of examples of these, and they'll get a little bit more complicated as time goes on. So let's get into those. So the first one that I did, much like we did in the previous video, I've got some structure set up here so that we can sort of, slow ourselves down and see what we're working with. So our first function here is the function x cubed. Okay, and our second function, the second thing that's being multiplied together to give us our function, is sine x. Okay, so you can see that what we're really working with here is there's an x cubed function, there's a sine x function, and we're just identifying this is the first thing, this is the second thing. Okay, so the next thing we need to do is we need to take the derivatives of these two pieces individually. The derivative of x cubed is 3x squared, and the derivative of sine x is cosine x. Okay, and then to do the derivative, the product rule tells us that we simply do the derivative of the first function, 3x squared, multiplied by the second function left alone, and then plus, we leave the first function alone and multiply by the derivative of the second function. Okay. And we could leave our answer here, like this is acceptable, but I will point out that very, very commonly there is a lot of value in us factoring whenever possible. And this is something we'll get to sort of later in the video as well. But as you look through this derivative, are there any factors that these two terms both have in common? Well, they both have, this has an x squared, this has an x cubed, so we could actually factor x squared out of this. If I factored out x squared, I'd be left with 3 sine x from the first term and x cosine x from the second term. Again, if the problem is just asking for the derivative, this isn't strictly necessary, but if we're going to be going anywhere after this, if the problem is going to ask us about stationary points or some other things, being able to factor it first is a really valuable thing. Okay, so now we have this next one, another example of a product rule. This one I don't have the structures, written explicitly on the thing, but I'll keep doing them just so we can sort of see it. Hopefully we recognize that our first function is x to the fourth, and my second function is the natural log of x. Okay. In order to do the product rule, we're going to do the derivative of this one, and we're going to do the derivative of this one. And then just as we did in the previous video, not the previous video, in the previous problem, we let these things take turns being derivatives. First we let 4x cubed be the derivative, and we multiply it by the original function, plus, in this one we leave the first function alone and multiply by the derivative of the second function. Okay. Now just like we did in the previous one, I'd like us to take a moment to see what we can do to simplify this, and then see if you can factor anything. So if you haven't paused the video and done this one on your own, pause and simplify for a moment on your own. So what I'm noticing that we can do here is we can certainly, sorry, that got really messy. We can certainly make this over here x cubed. And then at this point, these both have an x cubed term in them. And since they both have an x cubed term, we can factor that out and wind up with this as our fully simplified derivative of the function. Okay, so I've got one more sort of basic-ish example before we get into some other ones that are a little bit more complicated. So if you haven't given yourself a chance to do one of these on your own, make sure you pause the video now and try this one. I will continue to sort of show what the two parts of this are. We see that the first function here is 2 cosine x, and the second function is sine x. Taking these derivatives, I get negative 2 sine x, and I get cosine x. So then, unsurprisingly, to do the derivative here, we use the product rule. I'm going to do the derivative of the first function times the second function. Well, when I have sine x times sine x, we can really just express that as sine squared of x. Okay. And then similarly here, when I do 2 cosine x times cosine x, I can express this as 2 cosine squared x. Now, when we talk about factoring, I suppose that here you could factor out a 2. I don't know that factoring out a constant really does a whole lot for us. So in my mind, I would probably leave this one here. If I did anything, like if I just really felt like taking another step here, I would probably switch these terms around, because it's kind of nice to not have a negative in the front. But honestly, there's nothing wrong with either one of these. These are both totally acceptable expressions for the derivative of this function that we're working with. So in this next example, in these next two examples, in fact, actually 3 examples, I need and want you guys to recognize and know that it's not like a problem is either a product rule problem or a chain rule problem. Sometimes you get a case where the two of them mix together. And so when we're looking at this problem, you know, I might ask you to pause the video, or if you can think about it quickly on your own, is this problem going to require the product rule? And if so, why? Right. Well, one reason that we might certainly give for why it is going to require the product rule is that there's an x to the 5th right here, and then it's multiplied by the cosine of 3x minus 4. Right? So I definitely have two things here, and they're definitely being multiplied together. And so because they're being multiplied together, I'm going to have to use the product rule. Right? So, but you may notice that this cosine expression right here has something plugged into it. And so because of that, that thing is going to require the chain rule when we get to doing its derivative. So similar to what we've done on the other slides, I'm going to go ahead and break this into the pieces so we can see it. My first function is x to the 5th, and my second function is the cosine of 3x minus 4. All right? Now, the derivative of this first thing is really easy. This is just 5x to the 4th. I don't want to say that the second thing is hard, but I hope you guys recognize that this thing over here definitely is a chain rule problem. Right? Now recall from our last video, or the last thing that we learned, the derivative of cosine is going to be negative sine of, and then we're supposed to leave the inside alone, and then multiply by the derivative of what was inside. Okay? So I'm actually going to take a moment there and even make that a little more clear. This is going to be our derivative for that. So now that I have a derivative for the first thing and a derivative for the second thing, now I can actually take the time to write out what the derivative of the whole function is, which is going to use the product rule. Okay, we're going to do the derivative of the first term and leave the second term alone. So 5x to the 4th, cosine of 3x minus 4. And then we're going to do plus, yeah, I'll go ahead and do it as plus. Plus, we're going to leave the first function alone and multiply by the derivative of the second thing. So this would be x to the 5th times negative 3 sine of 3x minus 4. And there's some beautification that can be done here. We can make this 5x to the 4th cosine of 3x minus 4. Over here, I'm going to pull this thing to the front and make it negative 3 x to the 5th sine of 3x minus 4. And I think the very last thing I'm going to do here is I am going to remind you guys that this idea of factoring is still a really valuable thing. So when we look at these two terms, what is it that they have in common that can be factored out? Hopefully you notice that really the only thing that they have in common that can be factored out are some of these x's. I do want to point out that this 3x minus 4 looks like it's the same, and it is, but I can't factor it out because it's inside of a sine and a cosine. So I am going to, didn't mean to be using blue there, I'm going to be factoring out x to the 4th. That leaves me with 5 cosine 3x minus 4 minus 3x sine of 3x minus 4. Okay. So you can see that when you've got a product rule and a chain rule involved together, these can definitely get a little bit more complicated. But if we're careful about how we apply the rule and look through it carefully, I don't think you guys are going to have a huge problem with it. So here we have another problem where we've got a product rule and a chain rule or some chain rules that are going to be happening at the same time. So I'd like you guys to pause the video here, work through this one and see what you can do about factoring the thing at the end. There's definitely some complication there, so we'll go through it together when you're done trying it. So the first function here, we've got this x minus 4 cubed, and our second function we've got 2x plus 3 to the fourth. All right, so for this first one, I'm going to have 3, leave the inside alone, and square it. The chain rule there says I then need to multiply by the derivative of what was inside. That's just 1, so it's not really going to change anything, but it's good for us to recognize it. On the second one, this derivative will be 4, 2x plus 3 cubed times derivative of the inside is going to give me 2. So I want to simplify those a little bit. This is going to give me 3x minus 4 squared, and this one over here would be 8 2x plus 3 cubed. Right? So now, to do our product rule, we just need to put these things together in the right order. I'm going to do the derivative of the first one times the second one, and then the first one times the derivative of the second one. Okay. When I do that, by the way, I'm going to put the 8 in the front right away just to sort of save a step on simplifying. So this derivative is going to be 3x minus 4 squared times 2x plus 3 to the fourth, and then plus, I'm going to do 8 from the second part, and then x minus 4 cubed times 2x plus 3 cubed. Now, that's the derivative, and this is acceptable, but the problem did say find and fully factorize using our British spelling of factorize. What do these two things have in common? What factors do these things share that could be factored out? And if you haven't already thought about this, pause the video and look at it for yourself. It's actually some really, really interesting stuff. What these guys have in common is they both have factors of x minus 4, and they also both have factors of 2x plus 3, right? Now, we can see here that they have, this one has 2 factors and this one has 3 factors. So what they have in common is 2 factors of those things. So I could factor out x minus 4 squared. And then from the other things, these 2x plus 3's, the first term had 4 of those factors. This one has 3 of those factors. So in terms of what they have in common, they have 3 of those factors, so I can factor out 3 of them. Now, when I factor all of that out, what's left behind? Like if we go back and look at this first term here, this first term still has the 3, and it still has one of these guys. And when we think about the other term, this one still has an 8, and it still has one of these guys. So when we get to what's left over here, what we have is we have 3 times that one lone 2x plus 3 factor that was left, plus 8 times the lone x minus 4 factor that's left. And then we can actually simplify even this thing over here. This is 6x plus 9 plus 8x minus 32. Oops, just realized that I left that thing in there. That shouldn't really be there. Our bracket should be over here. And so I can finally combine all this stuff together over here to give me 14x minus 23. And then I can put that together with the rest of my problem to give me my final factorized derivative of this thing. Sorry, that got a little bit messy at the end there. I hope that one made sense. I do have one more example. I know that this is a long thing, but I hope that the next one makes sense for you guys as well. All right, so in this last one, there's a product rule and there's a chain rule here, but it's a little bit different. So hopefully you still got some energy left. Pause the video and take a look at this one. See if you can get a sense for why this is a little bit different of a product rule and a chain rule. So what I hope you guys notice is that this is definitely a chain rule because we've got sine with something plugged into it. But the thing is that the thing plugged into it is multiplied, right? So there's kind of this idea that when I do the derivative for this thing, I know that I want to do the chain rule. I know that I want to do cosine of leave the inside alone, times, now I'm supposed to multiply by the derivative of what was inside, but at that moment right there, we're now thinking, hey, what's the derivative of what's inside? That thing inside is a product. So I'm going to need to multiply by the result of the product rule. Okay, this is, at this point, I hope this is a really simple product rule for you guys. We're just doing the derivative of the first term times the second term plus the first term times the derivative of the second term. Okay, and in a lot of ways, that's the end of this. I know that it's been a long video, but I will say that the one last thing that we can do here is we can look for common factors. There's factors of x in both of these. There's factors of e to the x in both of these, so we can actually factor those things out. So we can have cosine of x cubed e to the x times, let's see here, we could factor out x squared and e to the x. And when I factor those out, what's left is 3 from the first term and x from the second term. And so if I really wanted to write this all out in order, I would probably choose to put the x squared first, then the e to the x, then the 3 plus x. I really just don't like anything coming after my trig functions. So my personal preference would be that we go with something like this for our final statement of the derivative. So we've got the product rule. There's a lot more things we can take the derivative of now, and remember that it can combine with things like the chain rule. So I hope that all made sense, yeah, good luck.